Hey guys, we're back on my 1978 Power Wagon. If you've been following along, this has a 483 stroker that was built by JMZ Online, and that whole series is available for you guys to watch, by the way. But we are putting a Holley Terminator X stealth injection system in this. And in this installation of this series, is that the right word, installation? I feel like it's not. In this segment of our build, what I want to talk about today is mounting the wiring harness and some wiring discrepancies that I found along the way. Join us in this one. It is something that will be very useful for those of you that are interested in putting one of these systems on your car. You're going to see how much you can modify this system, as well as the advantages and settings you can change that are tailored to your build. Pretty cool stuff. Stay with us for this one. Step one, come here, look at this diagram. So you see this little thing right there? That's what they want inside the car. So it's like a firewall. Basically everything that's from here in, you really want to put this inside the car. Okay, when I first started building this, I had my CAN connectors were outside. I had the fuse and relay outside. I kind of stopped it here. That was a mistake because I still would have had to run the CAN wires through, because that's inside the truck, through the firewall to reach them. I did want the relay and fuse out under the hood. That's for the fuel pump, by the way. But yeah, so we want all of this inside. The other thing I did wrong when I routed this is the main harness. This is the one that goes to the battery. Back on this paper, firewall connection, right? Or firewall. This is your main battery one. I forgot to run these. So as I'm routing this, oh, and then the vacuum line too, I had to run that. I would have liked this diagram to have had these run up this way through this connector and then back down. Just as a reminder, it's just a generic picture. It's not like complete, but as a guide for your wiring. One of the hard parts about doing this job was placing your wiring. Where are you putting everything? Because this didn't come with any of this, so we're kind of doing fabrication work. So I'd spent my time here drilling a hole in the firewall, which I never wanted to really do in the first place. But anyway, I drilled the hole. I got this old grommet from like a Ford that was at my brother's shop. I pulled it off of a wiring harness. But I ran this one really nice after I made some mistakes, and I moved everything inside, my CAN connectors, my relay for my fuse, the relay for the fuel pump, and the fuse is all in there. I forgot to run this wire. That's my main battery feeds. That's these guys. Let's see. I still got to shorten these a little more, but we're going to fuse protect the power feed, go to the battery, negative, go to the battery. But I forgot to run that. And then I also forgot to run the vacuum hose, and I had this all taped up and nice and pretty. And when you do this kind of work, you don't want to undo what you're doing. And so it kind of looks like spaghetti right now. Like I have wires kind of everywhere right now because I learned my lesson, which is don't mount everything and tape everything up and zip tie it, make it look all pretty until you figure out where everything's going. That's been difficult for me. All right, so the purpose though for this video is I want to talk about these types of discrepancies. One of them was harness routing, right? Let me show you inside real quick and why we want what they're showing at that firewall connection, why we want it inside. Number one, the module, of course, is going to be a lot safer out of the weather. It was recommended that you mount it inside. Number two was access to the LEDs that are on front of this computer. What I have learned is you don't necessarily need these lights when it comes to your everyday driving. When it comes to troubleshooting, there's things that we can use in those lights, but they don't need to be exposed to you. But I mounted it this way for that reason. I also have my display up here, but you can see I'm connected to one of the CAN connectors. There's two of them. Either one you can connect to. They both really go to the same place, but CAN 1 is your directions when it tells you to hook up for that. But you want that inside. You're gonna have this inside, otherwise you're gonna have to extend this wire all the way out. This is your main power feed connection coming in, 2-pin, that's going out to the battery. I really don't like the idea of this fuse being in here. This wire to the left is the one that runs through my firewall and underneath and all the way to the battery, is not fuse protected. I know there's a fuse right here, but all that's doing is protecting this little piece of wire from here to here, and then the module itself. If the module would short and something happens internal to that, yes, this fuse will blow. So that's good. We're protecting our wiring harness from a module short. We're not really protecting the harness when you just have a little 6-inch piece of wire that you're protecting. Really, we need to protect this part from here out. I'm relocating this, I'm telling you right now. I'm gonna take these 2 wires, put them together with a crimp style heat shrink butt connector, and I'm gonna take this guy and I'm gonna put this right on the battery. That way I'm protecting the whole wire. Same way with this one. This other fuse right here is for the fuel pump circuit. It's protecting the fuel pump, and this is the fuel pump relay. And again, having this inside is good. They didn't give you a weather pack cover for this. It's made for one, but this being inside, I don't need one. Same thing with the fuel pump. Like that circuit, this fuel pump circuit, that fuse relay for the fuel pump, let me show you under the hood. This red wire goes to that. It's fuse protected in there. But what happens if this red wire that goes over that way into the main harness right here, this red wire right here, and that's the harness I'm lifting up on down here where my finger is. Can you see that? Mm-hmm. That's the main Holley harness. That's the feed to your fuel pump. And then this green wire goes to the pump. What happens if the green wire shorts to ground? No problem. That fuse inside will protect it. But if the red wire that's out here up to the fuse up there shorts to ground, there's nothing protecting it. If that red wire shorts in my makeshift hole that I put in my firewall and rubs inside on something metal, that wire is gonna burn, and that fuse is not gonna protect it. So I'm adding a fuse up here. My inline fuse is gonna be here. So yes, we have 2 fuses now on our fuel pump circuit. It only needed this one. It only needed this one. And as I'm thinking about that now too, I'm like, I don't like this one because it's not really weather pack. I may end up doing the same thing with that fuse up there. I may end up cutting that wire, splicing it together, and bringing that fuse up here to fully protect this circuit. So in my opinion, I think those are design flaws. There may be a reason why they did it that way. I'll show you a little bit more detail on the fuel pump circuit, the wiring and all that later. I just want to talk about the issues that I ran into and the things I'm doing from problems that I'm seeing. And those fuses, to me, those are problems. They need to be corrected. That fuse needs to be way out here next to the battery for the main feed, and the fuse for the fuel pump main feed that goes to the load side of the relay needs to be out here too, okay? Some other confusing points for me. This is the vacuum line to the map sensor that's built into the module. Being that I'm not turboing or boosting this engine, I can use the 1-bar map that's inside of here, which is the plan. And these fittings that they gave me, right? There was 3 of them. You can see one of them I'm using. These came in the oxygen sensor bung hole, the bung hole package. So with the O2 bung, they had the map sensor vacuum adapters. That was weird. I was like, what are these things? Because I was looking at them with the oxygen sensor bung, and I'm like, well, what are these things? I had to get with support and ask them about it. And I'm like, oh, that makes perfect sense. Not sure why they packaged those together, but be aware of that. That's where you'll find your adapters, where I can go to this plastic vacuum line into rubber. Those adapters came with the oxygen sensor bung. Okay, they were in that package. Notice my computer wiring is not plugged into the computer yet. This will be the last connection according to Holley's service info. They want you doing these last. After you get all your wiring done under the hood and everything's bolted up, do this last. And I understand why. In case you do something wrong, you don't want to smoke the module, right? So continuing with the main harness discussion first, and then in our next segment, we'll talk about the extra loose wires and what to do with those. But let's talk about the main harness. There's some things that you'll see in this, like a 3-wire pressure sensor that doesn't plug into anything. That is a standard connector that would go to really any GM style, not just GM, I think Chrysler used the same style too, the map sensor. This would be for if I was boosting this engine and I needed more than a 1-bar map, I could put a different map sensor in there, and then I can go into the program and I can tell it what map sensor to use. I can say, hey, ignore the internal map sensor, use the external map sensor. That's what that guy's for. I'm not going to use that in my application, so I got to figure out what I'm going to do with him. The main plug here for the throttle body, this is going to include all 4 fuel injectors are in here, as well as the throttle position sensor, which is right here. The wiring for that's going to be in here, as well as a 4-wire idle air control device. Probably a stepper motor that's in here. I'm not totally sure yet, but 4 of those wires for an idle air control device. And I believe there's also an internal manifold air temp sensor that is part of this, all in this diagram, or all in this connector, which we can see in a wiring diagram. I'm going to show you guys that too. Then we have this guy right here, is plugged in. You're not going to see it. It's a 3-wire sensor that goes in the back here. That is for my oil pressure. I'll be able to monitor oil pressure with my system. And then I also have a connector. I have it unplugged right now. Let me find it. This guy right here, 3-wire pressure sensor. This goes to my fuel pressure regulator, and that's the high pressure side. I adapted this piece into it, and I will be able to monitor fuel pressure too from inside. And then we have right here, 2-wire coolant temp sensor as part of the main harness. And this stuff's marked coolant temp sensor, CTS. That's not OBD2 standard codes though, terms. That would be an ECT if we're talking about OBD2 standards, ECT being engine coolant temperature. CTS is what all of the lay people call them. CTS, coolant temp sensor, 2-pin thermistor, basic stuff. The 3-pin connector for my distributor, that's this guy right here. This is just a Hall effect, and it goes into a connector that has a whole bunch of other wires. 1, 2, 3, 4, there's 6 wires that go into this. This is a universal system that can adapt to multiple different ignition systems. So on mine, I have an adapter that converts this to my specific use of this 3-wire Hall effect, right? Plug and play stuff. Awesome. Love that. The other one that was a little confusing to me at first was my wideband oxygen sensor, which is this guy over here. So I'm using a 6-wire wideband sensor, but this is designed to work with many different ones, and this is an 8-pin plug. So there's an adapter that I have to take the 8-pin down to 6 and use it for my application. And what's really cool about the service info that they provide, they actually give you part numbers for various sensors that are compatible, and you can program the system to use the one that you bought or the one that you have. A really highly customizable system from what I'm seeing. I'm anxious to get into the tuning part of this and making all those settings. We're going to do those with you guys too. All right. Pretty straightforward with that stuff. Once you got your crap mounted inside where you want it, the fuses we talked about, not too many discrepancies with the plugs, except for these 2 guys back here. This one is called inputs and outputs, and then this one is called a power tap. So the input output one, this is going to be like cooling fan control. I also have inputs that I can send into this, whether it be pull up or pull down, say like a brake switch input. And on one car, that brake switch input that you may use for whatever is switched on the power side, and on another car it's switched on the ground side, and you can pick the inputs that you're using coordinated with the terminals, and you can switch them on the program, which is awesome. You can switch it to be a pull up design or a pull down design. Pretty freaking sweet. This is a tap that goes into that green, actually ties into the fuel pump circuit. The orange is a 5-volt ref. the black and white is a sensor ground, and then the black is a chassis ground. So this is a power tap where you can, you know, I don't know what you would use that for offhand, but that's what those are for. I want to show you that part on a diagram. So this generic diagram, which is mostly what I was going off of until I had one of the service techs send me an actual diagram. The inputs and outputs that I just described, that's all they give you on this diagram. Notice like there's no pin designations at all, but it does tell you fans, AC kicks. So if I wanted to run electric cooling fans, I can use one of the outputs to trigger a relay to run the fan. And I'm sure I have full control of that. I was actually asking the guy about the outputs, and you can take an output that, say it's a ground side switched output, and you can make it a pulse width modulated ground. You can either switch it to all the time, or you can make it pulse width modulated, and you can actually control the pulse width length, the duty cycle, to control the speed of whatever it is that you're. That's freaking awesome. That's freaking awesome. The power tap is nowhere on here. And notice my oil pressure sensor is not on here. The only reason I knew what it was is it's marked clearly on the harness, but the oil pressure sensor is missing on this too. And I'll show you that on the other diagram, it's missing as well. This next part, guys, I want to talk about these 4 wires, these 5 wires that are here, the yellow, the black, the green, the white, and the red. We want to talk about these. They called them loose wires, and they were loose. They didn't go anywhere. No terminal ends, as you can see on the end of this yellow wire. The rest of them I have routed in my factory harness already going over that way. But I want to talk about these wires because especially this yellow one, I had some concerns here. Red wire's got to run over to the battery. We talked about that with a fuse. Black wire is going to go to chassis ground. Green's going to go to my fuel pump. That one's already fuse protected down in here. And then white and yellow. So now we need ignition. This is generic because there's many different ignition designs that this is compatible with. In my application, I'm going with a Hyperspark module, and I'm going with a Hyperspark distributor. Distributor signal right here goes into the ECU as a square wave, one for each cylinder, and then you're going to get an electronic spark timing signal, which they call this on the diagram your points output. A point type, what do points do? Points control your ignition system. A points output is a horrible name, in my opinion, for what that thing is actually doing. Whatever. Points output is what they're calling it. That is your electronic spark timing signal that's going to have engine temperature, engine load, engine speed, engine parameters, all programmed in there, sending a altered pulse signal out to this guy, and then this guy is going to switch on and off at the right time this ignition coil and make it fire with our electronic spark timing. Okay, very simplified system for me because I'm using what was really designed for this system. You can modify these. They'll actually run like a Ford TFI ignition system. You can use everything that's there. They'll run a GM, I believe the 7-pin GM designs of the HEI. You can run those too, and the computer can control timing. So a highly adaptable system. But for me, I had to figure out which one I was using. You can see in the Hyperspark system, they're giving you different wiring designs. Right, this happens to be me up here, right? Nice and simple. Just 2 pins go into the coil from the module, power and a ground, and then they show me just the white wire, which I described to you guys, and then the red goes to an ignition source, ignition positive for the red. So we power that guy up only with the key on. We don't want that guy hot all the time, only with the key on. But all I need is the white. So then what about the yellow? What do I do with this yellow? What's it used for? What's its design? My concern is if on one car that is coil negative, meaning switching the coil on and off, that means that this is an output. And if this wire touches ground, I will fry the computer driver for that circuit. So I needed to know what this did. right? This is an input, not an output. Huge piece of information that I needed to learn. This is an input for one of the other systems that I'm not running for a tachometer signal, engine RPM signal. Coil negative, it's an input. So we know when that coil is firing, then we know when that coil is firing so we can fire the injectors properly. That's what this would be used for. I'm not using that. It's an input. It's an input is my point. And if this wire touches ground, I'm not frying anything. I'm not even gonna be using it. I'll take steps to insulate that and protect it, but I'm gonna cut that back in the harness and tape it up and just get it away from stuff. But that was an important piece I needed to learn, is what that yellow wire was for. I feel like I'm forgetting something, but I think that's essentially it. I want to show you the diagram and make sure that you guys know at least where to find these, because having the actual diagram really helped me, but it also was a hindrance in a couple of these applications where I mentioned the input-output connector and then that power tap that's not listed anywhere on here, and it wasn't clear about what to do with this yellow wire either, and where it was tied in. But let me pull that diagram up for you guys. All right, if we need to, we can go through things in the comments with you guys. If you're ever building one of these, if you have any questions, I can try to help you. Unfortunately, I don't have a number of PDF for where, for this one. It was sent to me by Zach Roland, who was one of the tech support guys. The main thing I want to talk about is that guy right there. So as I'm going through my diagram, I'm looking at it and I can see, okay, this is my fuel pressure sensor because it says fuel right there. And then I'm looking for another 3-pin connector. I don't see one. Okay, I see a 2-pin connector over here. It's labeled CTS. That's really cool. I didn't like my initial view of the diagram because there were no colors, but I really like this now because if you look, it says A19, and you just follow this over to A19, there's your wire color right there. I didn't anticipate the wire colors being over here. This is a lot different of a diagram than what I've seen. But I really like the designation A19. It's telling me over here that this goes to pin A19 on the ECU. That's freaking awesome. I like that. The fuel sensor's the same way. Look, the A, B, and C connector, that's A18, A26, and A31. Cool stuff. A18 is my sensor ground. A26 is my 5-volt reference. A31, that's going to be my signal. It has to be. A31's purple. It's my fuel pressure signal. So good stuff. I like that. But I go to this one and I'm looking at this guy. I'm like, well, that's got to be my oil pressure sensor because nowhere else on here is a 3-pin connector. And I look at it and I'm like, okay, B12, B10, and B3. And I look at this, go to B12. B12 says PWM #1 out. Pulse width modulation #1. That's not the oil pressure sensor. We don't pulse width modulate anything on an oil pressure sensor. Then I look at B10 over here is PWM #3 out. And then I look at C, which is B3, and B3 says PWM #4. I'm like, what is this? Well, look close at this. It does say IO, which is my input-output connector. How many pins do we see on this diagram? I see 3. How many are on that input-output connector? There's like 8. So I get with my buddy, and I'm like, dude, you gotta help me make sense of this. Like, what is going on here? And this information here is in this pamphlet. So I saw it, it's right here. I just, kind of blew right past it. Additional inputs and outputs. And my issue, I guess, was it tells you a little bit about it, like electric fan, AC shutdown, AC kick. What else? Fan #1 output. So yeah, things, right? But like the connector's not there. And so he sent me that. I'm like, well, that's cool, but tell me about this 3 pins that are on the diagram. And I want to say that this picture is not on the pamphlet. This is just describing the input-output connector on the Terminator X system. And my inputs, frequency, a digital signal typically used for a speed input, 0 to 5 volt for a 0 to 5 volt sensor input. And I can change all of these for what I want. a 0-20 volt input, a thermistor, what's called a high or what's called a ground. I would call these two pull up and pull down circuits. You guys have been following me on inputs. That's what this is talking about. And we can switch any of these two. You see these designations up here can be configured as. So let's just take one input, right? The A12 input. And it can be configured with F, 5, H, or G. What's F? A frequency input. What's 5? 5 is a 0 to 5 volt input. H is a high input, switched high, so meaning when it's on, it's high, 12 volts, right? Pull up. Or G is a ground, used for ground switched input. So a circuit that when you close the switch, it grounds it. We can change all of these. How cool is that? On this input-output connector, all of the inputs can be changed to whatever I am connecting to. And then the gray, yellow, gray, red, gray, black, gray, green, these are all outputs, and they can be G or P minus. So what's G? A ground. So that would be a switched ground. So say like a relay, you want to turn a cooling fan on and you want to control the ground of the relay. You'd make the computer ground it and you tell the computer which pin you have that set up on and tell it what temperature you want your fans to come on. Ground the fan. That's pretty sweet. The P negative, the P minus is the other setting. I can use it for ground pulse width modulated output. So I can't think of a specific ground side pulse width modulated circuit offhand that you'd want to use. My apologies on that front, but that's pretty cool that I can switch it from a constant ground to a pulse width modulated ground. That info I didn't find in this book. And I hope I'm not misquoting Holley here, but that's kind of important information in my opinion that one would want to have. All of these ignition diagrams didn't help me. Remember the yellow wire I was talking about? Yeah, what's it say? Not used, not used, not used, not used, not used, not used. Some of these it is being used. There you go, here's coil negative. It's being used on coil negative for a system that is not computer controlled spark, right? We're just monitoring our RPM based on that yellow wire on these guys. It's an input, but I needed to know that. Like I said, sometimes it helps to talk to somebody too, and what you think is not there in the service info actually is. I'm not seeing that page anywhere in here. So that was a discrepancy. Here's my power tap for anyone who wants info on the power tap and what each of those are. Green's a fuel pump. I'm not sure on what circuit we'd want to monitor the fuel pump, but yeah, you can tap in right there. That's tied into the fuel pump power feed. Maybe you want, something else to only turn on when the fuel pump is running. That'd be a wire you could tap into. 5-volt reference, sensor ground, chassis ground. I had mentioned that to you guys. That is nowhere in the diagram either. And then he sent me this. So I do have a part number, at least for this diagram. It's 271R960A, the Holley EFI multi-port fuel injection main harness. I'm not running multi-port, but check this out. Oh, if I didn't say it, by the way, our confusion here. This input-output connector, that's just a partial view. That's my guy that's got 8 terminals. I did say that. So looking at my picture, so this is from Holley. There's my input-output connector, and it shows you the 8 terminals. 1, 2, 3, 4, 5, 6, 7, 8. And it does go through, I think like B10 was one of them. B10's one of the ones. It says PWM number 3 out. B10. PWM number 3 out. So even though it's not the same diagram that we're dealing with, that gives you the rest of these input and outputs. And so that will be useful for some of you guys that are running this system where you want to do other things and you don't have the rest of that connector to tell you what's in there. You want this diagram, or just follow the pin numbers and what they do, which, by the way, this is my input output harness connector, and you see all the wires that come with it. And this would be something I probably won't use, at least for any near future, but down the road, I may take one of these outputs and control a cooling fan relay with it, which I think is just phenomenal to have the option of all these other inputs and outputs that I can control based on the system that you're putting in, you know, based on the car that you're putting this system in. Pretty sweet that comes with that connector. What will I do with the connector being exposed? I wish that Holley would have provided a dummy plug to plug into that to seal it. And what I'm thinking, you don't want to use dielectric grease for contacts because it's an insulator. But what I'm thinking is just filling it with dielectric grease over there and then taping it up. And then having it face down so water doesn't collect inside of it. Should be good enough to keep it from being corroded. Typically circuits that aren't functioning won't corrode. As an example, we just did a case study today on an oxygen sensor heater circuit that the positive wire was heavily corroded by somebody tapping into it and not sealing it. But the sensor signal wire was also tapped into, but it wasn't corroded. And I see this a lot. Very, very low voltage circuits do not corrode like 12 volt circuits do. And maybe an inactive input-output circuit, which this would be, may not even corrode at all, which is why they never bothered sending you any kind of, you know, weather-packed plug to cover it up. But I have to do that with the input-output connector and then that power tap. I need to insulate both of those, as well as the map sensor, the 3-wire map sensor. I want to do that as well. But last piece on this diagram before we close this out. Just want to be clear on what this bulkhead is. It was confusing to me for a little bit. I don't like that they called it the bulkhead. I don't know why they just didn't call this the throttle body. That's the throttle body bulkhead connector. It is a bulkhead, but it's the throttle body. And the only way I was able to figure that out, like if you look at pin A18, again, these diagrams make it really nice to follow A18. I didn't even have to follow the wire. I just go to the pin. That says sensor ground. That didn't answer my question. Let's pick another one. Let's go A23. A23 is my map sensor. I know that my map sensor is, no, that doesn't help me either because that's external. The injectors are in here is my point. I was hoping I'd pick the first one to be the injector. A5, where's A5? A5 TPS signal, okay. I know that's part of that bulkhead connector in the throttle body. That's the throttle body. If you look down at the B connector, there's my injectors. Where's, let's see, injector DB13, where's that go? Yeah, you see that B13 is part of that bulkhead. So bulkhead on that diagram is the throttle body. All right, let's go back over here. So what are my thoughts overall on this? I haven't run it yet, so we have a lot of opinions that are gonna vary and change, and my hopes are that my opinions stay positive. But overall, I'm very, very pleased with what I'm seeing. Other than the fuse locations. Easily fixable. I don't like the fuses inside. Yes, they protect the computer from a short. Yes, they protect if the fuel pump shorts, but does not protect my wiring on my, this is my baby. And I'm not taking any chances. If that wire touches before the fuse, the wire is gonna burn. Those fuses need to be out here. So that's one correction I think Holley needs to make. Other than that, excellent design so far. And everything was pretty straightforward except for the variables that we talked about. I had to research. If I can offer any suggestions to you guys, don't permanently mount anything. Just don't. You're gonna probably take it apart 5 times and before you decide that's where you want it. So yeah, more to come. This was really just one piece of this process, and we're really looking forward to getting this thing running and having you guys hear the first start, and all of that is coming up. So stay tuned for our Holley Terminator X stealth install on this 1978 Dodge Power Wagon with a 483 stroker built by Jamsey Online. You guys, there's a whole series on this engine at the machine shop and all the fancy stuff they did to it. We're pushing, I did the math, actual numbers plus 15% for altitude. We're like 630 foot-pounds of torque, and I believe, what was I forget the horsepower number, hold on. An actual number made 504 horsepower, but we were at 5,000 feet, and Nick told me that it's 3% per 1,000 feet. So 504 times 15% is another 75 horsepower. 504 plus 75, yeah, 579. So we're at 579 horsepower and 630 foot-pounds of torque. So yeah, stay with us. This will be fun.